This is the Convergent Science Network podcast. Leading researchers in the domain of neuroscience, brain theory, and technology are interviewed by Paul Verschure and Tony Prescott.
So this is Tony Prescott for the Convergent Science Network podcasts from the Barcelona Summer School on Cognition, Brain and Technology in 2011. And I'm here with Huosheng Hu from the University of Essex Department of Computer Science and Electronic Engineering, who is one of the speakers that we have this week on the general topic of biomimetic robots. So, Huosheng, can you tell me a little bit about your background and how you became a roboticist?
I came to this country, UK, 25 years ago. And before that, I was working in the Chinese university. My major is automation. So when I joined Oxford University, worked with Professor Mike Brady, I started doing robotics. So that will be back to 1987. So I started working with industry, try to produce the new generation of AGV for manufacturing of the industry. So start from there, and then I developed my interest in my research in the biomimetics or biological inspired robotics.
So you have some background in industrial robotics,
yeah,
but your work in recent times has been more directed towards service robotics,
yes,
and field robotics.
Yes.
So tell me about your interest in field robotics. How did you get involved in underwater robots?
Yeah, underwater robots is one kind of field robotics, and I'm also work on the wheeled and tracked robots and the flying robots as well. The reason I got into the underwater robots because we have industry approaching to us and try to create the robotic fish for London aquarium, because by law and they have many fish species cannot be displayed in the aquarium environment. So they want to create the robotic equivalent species for demonstrate how this fish species can swim in the sea, in the aquarium environment.
So you started off really building robot fish for exhibits.
Yes.
But you've started now moving them out into the ocean?
Yeah, just last 2 years, we have support from EU and FP7 framework, and we try to develop robotic fish to patrol ports and monitoring ship oil leaking problem, and also other kind of pollutions may cause the damage to the sea lives. So this is a 3-year project. We work with a number of partners in EU, like BMT and Irish partner, and also Thailand, and also Spanish partner as well.
So what would be the advantage in open sea of a robot fish compared to a conventional submarine-style robot?
Yeah, the fish, as we know, first thing is the swimming peacefully without disturbing environment, because submarine or ship-like, they use the thrust, generated a lot of turbulence in the water, which is no good for sea lives. And also is maybe disturbing pollution area as well. So fish is more peaceful and also more flexible in many of the narrow pathway, for example.
And what about energy efficiency? Is it similar or better than a submarine?
Yeah, as we know, the submarine type of the man-made ships, efficiency is up to 60%, but the fish theoretically is higher than the man-made vehicle, because after millions of years evolution, fish is excellent swimmer in the water. They have, of course, the body shape and make the fish swimming much efficient, and also the muscle movements also make the fish is very skillful as well.
So you're copying the streamlined shape of the fish, and you're also copying the type of movement it's making in order to propel itself.
Yeah.
Is the robot biomimetic in any other way, for instance, in terms of the components that you're using to build it? Or within the robot, are you using conventional motors and conventional
ideally, we hope many researchers actually use some kind of artificial muscle, try to mimic the real muscle movement of the fish. But at the moment, the artificial muscle is not mature enough for us to use it. So what we did, we use normally traditional, conventional motors to drive the fish movements.
And what about the pattern generation systems that are generating the swimming movement?
Yes, that's what we call the central pattern generator.
Yeah.
And that's generated by software.
Right.
And after we actually have used the camera to capture the real fish movements. We analyze the movements and then to decide the phase difference, because the real fish use muscles. So muscles can be considered as continuous actuator. But we use discrete motors. Motor has different size. Even we choose a small size, we only can accommodate 4 or 5 or 6 motors in one fish. So fish we build is about 60 centimeters length in total. So the half of the body with the 4 or 5 motors, that's we call the discrete joints to actually generate the S movement of the real fish.
Oh, okay. So is it a segmented body?
Yeah, segmented body, and each segment is actually one motor.
Right. And what about the fins? How many of the fins are you replicating, and how important are they?
Yeah, the fins is actually has the main dorsal fin, for example, is generated propeller force for our fish. And of course, fish also has anal fins, had the bacterial fins, and try to make sure the balance of the fish.
So you'd be using those for steering? And balance.
Yeah, that is only for the static balance. But once the fish move in the motion, and we really use the motor to drive it.
And what about sensors? What kind of sensors do you use?
We have a number of sensors inside of fish body, and one is gyroscope to actually measure the posture of the fish in the water to maintain the balance. We also had a force sensor to measure the depth in the water to decide the 3D swimming. And also we had the accelerometer to measure the speed of the fish as kind of a dormitory. We also have obstacle detection sensor, infrared, and to detect anything in front of the fish in order to avoid it. Of course, we had a voltage monitoring sensor to see whether the energy is enough or not. If the energy is not enough, we're going to floating on the surface.
Right.
Just in case.
Oh, okay. So you have, how do you control your height within the water?
To control the height in the water, and as we know, real fish has bladder.
Mm-hmm.
They can station in one level without motion. So we mimic the bladder function, use the water tank inside of the fish by pumping into the water or pump out of the water to actually change the weight of the fish, change the buoyancy. So this is only statically. But for the dynamically, you want to change the level of the fish, go up or go down. We actually use one motor to drive the central gravity towards the head or towards the tail. So in order to for the fish to swim up or swim down, very, very agile and very, very speed operation.
So I'm thinking about sort of pollution monitoring. So I can imagine that you might just have a boat and then you could trail something out of the side of the boat on the end of a line. How would having a robot that's submerged be better than other ways of doing that?
Because depends on the depth of the water you are going to monitoring. For example, we have the port in Spain. It's called Huosheng, and which has depths of 30 meters. So the pollution, if we use the ships on the surface, may not be able to detect anything beyond 10 meters or seabed, for example. So to use the fish, we can automatically to change the depths going to the seabed to actually detect anything pollution is there or not. Especially we want to search the source of the pollution.
So once you put your fish in the ocean, how does it know where to go and how to?
We actually use the structured environment. We put a buoy surrounding the port to send out the ultrasonic signal, sonar signal. And the fish has the receiver on board to receive the signal.
This is kind of like underwater GPS?
Yes, exactly.
Yeah. Right, okay. So it knows where it is, but you're never worried about that it won't come back?
Oh, yes. We actually have prevent in case of underwater GPS malfunction. Fish may get lost. So in that case, fish going to floating on the surface, we use GPS.
Right. So you can use the
GPS.
Satellite GPS.
Yes, because the antenna will be floating over the surface of the water. Then GPS signal can be received, and then we can navigate back to the home position.
So how close do you think we are to having a technology that might be commercialized for this sort of use?
Yeah, this project we are running now is third year. So hopefully we're going to test this in the port next year, next May. And after that, I think we need a couple more years refine it and improve the performance. I imagine maybe 3 or 4 years time from now on, we could have some commercial products on the market.
And what other application areas might there be beside pollution monitoring?
And also security. For example, and some of the coastline, they want to secure for different reasons. So we can use this kind of fish technology actually to detect any illegal ships or any illegal animation.
Right, yeah. So it could be part of the Coast Guard,
yes,
or it could be part of the Customs and Excise,
exactly.
These kinds of things.
Yes.
Okay, so changing subject a little bit, I know that you have an interest in building assistive robots for people with disabilities.
Yeah.
Can you give me an example of the kind of projects that you're doing there?
Yeah, this is try to help disable an aging population. Because when people getting old or people disabled, they have difficult to move around or independent life has been out of question. So what we try to help is mobility, to help these people move around, integrated with the society. And they can see the doctor if they want. They can see the relatives or friends, go out if they want. So that's the main purpose. As we know, currently, commercial wheelchair only been driven by joysticks. And many users have difficulties to navigate, use joystick, even go through the doorway. For example, users suffer Parkinson's disease. Their hand is shaking many times. They may not be able to use joysticks. And some of disabled people, they may be suffering no hand, for example. It's also difficult to use. So in that case, we think about the other means. For example, we use the voice, use the gesture, use the muscle signal, even for severe disabled users. We use like Professor Hawking, and cannot move any limbs. And then, if their brain function well, we use the EEG signal to control the wheelchair movements.
So you want to record EEG, sort of an electroencephalogram. So this is electrical activity from nerves, which you record by placing sensors on the skin.
Yes.
Yeah. And whereabouts would you put the sensors?
We actually nerves? Put the sensors in the skull, on the motor cortex area. Right. Okay. And the users actually can just imagine his hand movements, his or her neck movements, then generated control commands for the wheelchair to being controlled.
So this is the part of the brain, the motor cortex, which is anyway involved in motor control.
Yes.
And so you're hoping that by recording through the skull some of the electrical activity, you may be able to distinguish when the user wants to, say, turn left or wants to turn right.
That's right.
So, I mean, does this work? I mean, is it possible really to read these things from that kind of brain activity?
Right now, we actually have some results, although it's not real time, and sometimes the success rate is maybe up to 70%. So we think the key problem is the sensor. Right now, we use non-invasive electrode on the skull, and the signal is very weak. So we have to improve the sensor technology. So we hope by next few years, if the EEG sensor can be further improved, then we can use such technology. This is one thing. And also on the other thing is we think maybe multiple modality, not just EEG, and also a facial, also other biosignal can be helped combined with EEG if possible.
What other kind of signal are you thinking of?
Like a facial emotion, facial eye movements, and mouth movements. Simply that clue also can reflect people's needs. Okay.
So if I'm a wheelchair user and I'm wired up with these electrodes on my head, what do I have to do to make the wheelchair move? Is it enough that I think I want to go left and then it will turn, or do I have to learn the relationship between my thought patterns and what the wheelchair does?
Yes, we do need a training.
Right.
We need every user to training, generate imaginary signal. For example, user can think about use the right hand or use the left hand or use the legs. So we can generate the electric pattern on the transducers. Then we need training we use the neural network, and we need to training all the parameters.
So you record these EEG patterns for people thinking about a particular kind of movement, and you train a neural network with those patterns to distinguish thoughts about moving left from thoughts about moving right. So roughly speaking, how much training data would you need? I mean, from a person, would you need several hours of EEG, or could you do it quite quickly?
We normally doing several hours.
Right.
We normally doing several hours.
And would that person, having trained on their data, would it be stationary, or would you need to train again? If you came back 2 weeks later, would it be different, or would it still work?
Yeah, that's a good question. Actually, people, they have diverges because their mental condition.
Mm-hmm.
For example, if user sleep very well last night, so today they may be function very well. If they are not sleep very well last night, they may not be get a useful signal today. So in that sense, our algorithm have to be more adaptive. So we call it online learning.
Right.
So what we want to do, not just offline, and also we want to online continuously change the parameters of our neural network, for example, to adapt to new stages of the mental stage of the users.
Okay, so where have you got to in terms of testing these? Have you got people driving around with wheelchairs and controlling them just with their thoughts? Have you got some prototype results now?
Yes, we do. We did. And we have, right now is health subject. It's all, in fact, our PhD students.
Right.
So next stage, we hope to get some disabled people or trial in the real users.
So how good are the students then? Can they, for instance, drive the wheelchair through a narrow doorway?
Yeah, and they can doing the navigate in the indoor environment in general, no problem.
Without bumping into things?
Yes, because the control system has prevent any bump into anything, use the sensors.
Oh, so there are sensors on the wheelchair as well to prevent collision. So so that you have a backup in case the brain reading system is not working very well.
Exactly.
So the wheelchair is independently sensing the environment and making some decisions about when to stop or when to go.
Yeah.
And then really what you're doing is reading the person's brain state in order to bias what the wheelchair is going to do.
Yeah, either EEG signal or muscle EMG signal, and also maybe other signal like a voice, like a hand gesture or head gesture, use the vision-based. This is all we call the hands-free control. It's on top of the navigation system. So all this human intention, biosignal, to detect by the sensors, use the control the wheelchair motion. But at the bottom of the wheelchair control system, we have safety control system there with the laser scanner, with the ultrasound sensors. They can monitor surrounding object of the wheelchair. If any object is close to the moving direction of the wheelchair, the human intention commands will be not executed because for safety issue.
Okay, so you're fairly confident that the wheelchair can move around safely with even if the person falls asleep.
Sure. Yeah, exactly. Or give the wrong commands.
Yeah.
Because sometimes that happens.
So I guess for when you want to use this in earnest, gluing electrodes to people's skulls isn't going to be very popular with wheelchair users. Have you got a plan for how to make this interface more easy to use?
Yes, what we're trying to do is we try to use wearable sensors.
Right.
And to put the sensor on the head.
Right.
Put the sensor on the maybe a glass, some sensors, and also put the sensors on the body or in the clothes.
Right.
Make the sensors wearable, portable, and compact. So people wouldn't how to say, people wouldn't bother by this kind of technology.
Right. And does the technology already exist for instance, voice control of wheelchairs?
The voice control wheelchair and has been developed for several years now, but not much use in the real situation because the background noise may cause problem, and also people with different accent, and also has little training as well. So I can imagine in the future, we have to combine different modality with the voice, for example, voice with the visual signal. For example, if we use microphone to catch up the human voice, at the same time, we use the camera to catch up the lip motion. So then we can confirm the user commands by tracking the lip motion and also the voice to emphasize, to actually make it more robust. Even background noise is very loud.
So you're confident that these kind of controlled wheelchairs then are going to be something that people will be using in maybe a few years' time?
That's exactly. Recently, we have a charity would like to invest in this area. So we have a plan to commercialize in 3 or 4 year time.
So moving sort of broader questions about robotics, what do you see as the really big challenges in the field in the next few years, the things that are maybe the bottlenecks that are stopping us from building more intelligent robots, more useful robots?
Right. I think that the key challenge is the sensing of the environment, sensing of the human intention. As we know, the robots is the integration of the sensor technology and also AI and the learning ability, of course, actuation side as well. I think 21st century is robotic century, means the robots can bring the benefit to our society to improve our quality of life, exactly like a computer technology, and change our lifestyle, change our working style in last century. So, but the key problem here now is how we created an interface between human and robots. And right now, there's still a bigger gap. All the robots have to be used by the people with training. And so if we want the robots going to individual home, the robots have to be easy to use without training on the programming side. Otherwise, still 80% of users wouldn't be able to use robots.
So to finish off then, what would be a prediction you might make about the future of our society and how we might be using robots in say 10 or 20 years from now? What can you think of an example of one big change that robotics is going to bring about in our society?
I think, as I said earlier, 21st century is a robotic century, and I can see a lot of different form of robots or different kind of robots going to enter our homes and hospitals and everywhere, especially for the dangerous situation like search and rescue work or like a nuclear disaster, these kind of things, and also many of the housework as well. I can imagine 20 years time, many of the robots going to be portable and also going to be wearable. And for example, in the future, our soldier in the battlefield may have some kind of GPS system located themselves and been tracking by the army for the safety purpose. And also many of the facilities at home with the robotic technology, for example, even like a fridge, they can tell users the milk is going finished. You have to bring milk from the a supermarket.
Or maybe get the robot to bring milk from the supermarket.
Yeah, and also remember, we can see some kind of iPhone is kind of robots as well, if that's the meaning.
Right. Well, thank you very much for talking to us. So this is Tony Prescott. I've been talking to Huosheng Hu. Thank you.
Thank you. Yeah, thank you very much.
The CSN podcast was produced by the Convergent Science Network of Biomimetics and Biohybrid Systems, a project funded by the European 7th Research Framework Programme. For more interviews, recorded lectures, or upcoming conferences in the field of biomimetics and biohybrid systems, go to csnnetwork.eu. And thank you for listening.